All right. So this is another question from your tutorial sheet, which is say the roots of the quadratic equation, this equation are alpha and beta. Find the value of uh, 1 over alpha plus 1 over beta. So basically these questions, what is very much important is for you to first find what alpha plus beta is and what alpha times beta is. So alpha plus beta is given by negative b over a, and then alpha times beta is given by c over a. So here it's just a matter of finding the actual values now. So negative b over a from this equation is going to be negative b over a is just going to be 6 over 2, which gives you 3. 6 over 2, which gives you 3. So when you talk about c over a will now be equal to 9 over 2, which is c over a. And then we'll quickly move on to now solving the questions that we've been given. So this is alpha times beta, and then this is alpha plus beta. So we have, so now we solve a. So our a will now be equal to 1 over alpha plus 1 over beta. So here what you do now is to find the common denominator, which is going to be equal to alpha beta. So the common denominator, basically you just multiply the two denominators, and then you get alpha beta. And then apart from that, you now begin to divide this alpha into alpha beta, you get beta. Beta times 1, you have your beta there. And then you have you write your plus there, and then this beta into alpha beta, you get your alpha. So alpha times 1, you get alpha there. So this can also be written as alpha plus beta. This can also be written as alpha plus beta over alpha beta. Yeah, so this can also be written as that. And then apart from that, uh, what we now need to find, at least we have now our alpha beta and our alpha plus beta there. So it's now even easier for us to find the final solution. Yeah, so the final solution now will be equal to, where there's alpha plus beta, we'll put 3. And then where there's alpha times beta, we'll put 9 over 2. 9 over 2, like that. Then here it's just a matter of dividing. So when you divide 3 by 9 over 2, this I think is just the same as 6 over uh, 6 over 9, if I'm not mistaken. So 6 over 9, which is just the same as 2 over 3. So this is the answer for the first part. Okay, so we move on to the next part. So this part is also simple. What you do is you just multiply, you just multiply this and that. So when you multiply the two, you're going to get something like alpha, and then you have your plus there, then you get your alpha beta, and then you get your positive 1. I'm multiplying these two here, because alpha times 1 you get alpha, alpha times beta you get alpha beta, and then 1 times 1 you get 1, 1 times beta you get beta. And then so you just put what is you just put, in short here you use what is called common sense. So you just put the alpha and the beta together. So you're going to have alpha and beta, you put them together, because I want something that will look at least like one of these. So at least I have my alpha plus beta there, and then I also already have my alpha beta there, and then plus 1. So where there's alpha plus beta, which is here, I'm going to put 3. So I'm going to write my 3 there. And then where there's alpha beta, I'm going to write my 9 over 2, and then plus 1. So here we can see that we have a silent denominator 1 even there. So we just find the common denominator there, which is going to be 2. And then you can finish it up just uh, by dividing this 1 into 2 is 2, 2 times 3 you get 6, and then 2 into 2 is 1, 1 times 9 you get 9, 1 into 1 is 2, 2 times 1 you get 1. So this will now give you something like 16 over 2, which is just 8. Okay, so we move on to the next question. So all these questions are very simple. You don't have to stress when answering them. And then we move on to C. So C here is saying alpha squared plus beta squared. So before I begin to answer C, because if you want, you can master the formula for alpha squared and beta squared. But if you can't manage to master, then you should know how to derive it. And then how do you derive such a thing? I'm seeing a question here. Let me just see what this person is talking about. Okay, he's asking to say not 17. So this is 9 plus 6. And then we have 2 plus, oh, here is supposed to be 2. Thank you very much for that correction. So here was supposed to have 2. Yeah, I wrote a 1. I don't know where I got the 1. So this will be equal to 17 over 2. Okay. So 17 over 2 is our final answer. Okay, so we quickly move on to the next question. So how do we derive this alpha squared plus beta squared? So we know to say that this alpha squared plus beta squared can be got, we can get it from alpha plus beta, and then we put these in brackets, and then we square them. So when we square these, we're going to have something like alpha times alpha, you get alpha squared, and then alpha times beta, you get alpha beta. So you discover that when you come and multiply beta times alpha, you also get another alpha beta, which implies that we're going to have something like 2 alpha beta there. So we have plus, and then here we have 2 alpha beta, and then plus we have beta squared again. So this is what you get. So we want to get some things which look like this. We already have alpha and beta there, and then we also, even this side, have to find something which looks like one of these. Then we have alpha times beta there. But when you look at this, this is alpha squared plus beta squared. So meaning we're going to put alpha squared and beta squared together. We have this alpha squared and that beta squared. We put them together. Okay, this is what we're going to do, and then plus 2 alpha beta. And then this side we already have our alpha plus beta, and then squared. So once you just take these 2 alpha plus beta square and 2 alpha plus beta to the other side of the equal sign, you're going to have something like this: alpha squared plus beta squared is equal to uh, alpha plus beta in brackets and then squared. When this 2 alpha beta goes to the other side of the equal sign, will become negative 2 alpha beta. Negative 2 alpha beta. So we now have our alpha and beta there. So you can see how I have derived this expression. So I'm going to have my alpha plus beta there in the brackets, which is 3. So I'll put my 3 there, then squared minus 2. Where there's alpha beta, I'll put 9 over 2. 9 over 2, like that. Then we have our 9 there. Then 3 squared gives us 9, and then even this side is giving us 9. So this is giving us 0. According to our solution here, it's like we're getting 0. Okay. So same applies to the remaining other solutions. You do the same. So let me just be simplifying them for you. You can be putting these. They are not difficult. So once you just simplify it up to this point, it becomes easier. The remaining things here is just replacing. While there's alpha beta, you put the number there. While there's alpha plus beta, you put the number. So let me just help you to simplify the remaining ones. So we move on to this one. How can you simplify that? So simplifying that will just be like how alpha squared, and then let me copy it, and then you have plus alpha, and then you have beta squared. So here you can factor out what is common. So we know to say alpha and beta are common there. We can factorize. So once I factorize, I'm going to remain with here. I'm just going to remain with 1 alpha, and then I don't know why this has started happening. Here I'm going to remain with 1 alpha, and then on this other one I'm going to remain with 1 beta, like that. So what this means is that while there's alpha plus beta, I'm going to put 9 over 2. I mean, while there's alpha plus beta, I'm going to put 3. Then while there's alpha beta, I'm going to put 9 over 2. Yeah, according to what we found to say alpha beta was 9 over 2, and then alpha plus beta was 3. So here I can put 9 over 2, and then I'll put my 3 there. Yeah, then I'll finish, and then you finish it up. 9 times 3 you get 18. Oh, sorry, 27. So 9 times 3 get 27. And then over 2. So minus that, so simple. Then alpha minus beta. So that's now what's it? This will give you alpha squared. Just remaining 10 minutes. Let me just finish simplifying these expressions. Okay, so I'm going to have alpha squared, then minus 2 alpha beta, and then yes, minus 2 alpha beta, and then you have plus beta squared. So this is what we're going to have. So what is important here now is just to pair what is known together. So you have your alpha squared plus beta squared, then minus 2 alpha minus 2 alpha beta. Okay. So minus 2 alpha beta. So where there's alpha plus, when there's alpha squared plus beta squared, you replace with what we found here. You remember we derived the formula for this, so meaning it's not that difficult for you guys to find it. It's so where there's alpha squared plus beta squared, you can replace it with alpha plus beta, and then this is how it was. Alpha plus beta, and then you have minus 2 alpha beta, then you write your minus 2 alpha beta again. So meaning your simplified expression will now look like this. then minus 4 alpha beta. So this is your simplified expression. So where there is alpha plus beta, you put 3. Where there is alpha beta, you put 9 over 2. And then you find your answer. So we quickly move on to the next question. Wow. So we are now on this question, which is alpha cubed plus beta cubed. So this question is also simple and straightforward. So simple and straightforward. So for you to find alpha cubed and plus beta cubed, it means that you have to at least find something which is like this: alpha plus beta, and then you raise this to power 3. Then you begin to multiply this: alpha plus beta, like that. You multiply alpha plus beta. So once you multiply, this simply means that you are this alpha plus beta is multiplying itself 3 times. So once you multiply this, you are going to have something like so you're going to have something like alpha plus, you're going to have something like alpha raised to power 3 plus, you get 3 alpha squared beta, you get 3 alpha squared beta. When you simplify this expression, and then you get another 3 alpha beta squared, and then lastly this side you get your beta cubed. So here it's just a matter of you uh, pairing the things that are needed. So we put our alpha cubed and beta cubed together because we want to come up with this. So we're going to put our alpha cubed and our beta cubed together. Then we write whatever that remains, we take whatever that remains to the other side of the equal sign. So this other side of the equal sign, we already have this alpha plus beta, then raised to power 3. Then so meaning we'll start taking these that side. So we're going to have negative 3 alpha squared beta, and then negative 3 alpha beta squared. So here it's just a matter of factorizing now. Yeah, so it's just as simple as that. If you want, you can replace the values just from there. So when we factorize this, we're going to have alpha beta outside, and then in brackets you're going to have alpha plus beta. So this is basically what you're going to have after factorizing it properly. So this is the expression for alpha cubed plus beta cubed. So if you can't manage to derive this, you can just master it if you're good at mastering. So you can just master it, and so that whenever you have such a question, it's easier for you to uh, do assist to solve it. You just retrieve whatever that you've mastered and begin to plug in the values. So what is important for you guys is to know how to derive these formulas. Okay, so let's quickly move on to these other ones. So you can see this one is simple. You just find the common denominator, then you cross multiply, you divide and multiply with the numerators. You know how we solve fractions. So this one is also simple. You do the same way. This one is also simple. You do the same way. Even this one, you do it the same way. So let me just do maybe one in the remaining 2 minutes, so that in the next session that we're going to have, we just do the last question, which is this one here. Okay. So let's quickly do one. I think let me do this one so that at least okay, time is even almost up. So we're going to have something like this, and then this is how It's going to be beta plus 1. So here you find the common denominator, which is alpha plus 1, and then beta plus 1, like that. Then so alpha plus 1 into alpha plus 1, you remain with that. So multiplied by 1, you're going to have this, and then the plus will come there. Then we divide that, you're going to have your alpha plus 1. So here you're going to have your alpha plus beta on top, then plus 1 will give you 2, then everything divided by, you multiply the denominators there. You're going to have alpha squared plus uh, alpha, sorry, not alpha squared. We're going to have alpha, you're going to have alpha plus alpha beta, then I think plus beta plus 1. So basically, or generally speaking, this expression, which is our denominator here, is exactly what we found here. So whatever expression that we found here is what you put as a denominator there, and then you replace where there is alpha times beta with 9 over 2, and then where there is alpha beta, you replace with 3. I mean, where there is alpha plus beta, you replace